So Nick's not going to be able to join us, but we are fortunate to have Vikram and Syed here. Moderating the panel will be Hani Ashahawi. Hani is the Managing Director of Novi Digitech, which partners with innovators, academics, startups, entrepreneurs, investors, and customers to create value and drive growth through integration, collaboration, digitalization, and education. Hani recently retired from Shell, where he spent the last 18 years as deepwater digitalization lead, formation testing and sampling principal, technical expert, game changer, deepwater technology advisor, and capabilities manager, and as leader of the Shell's Fluid Evaluation and Sampling Technology Center of Excellence. Prior to Shell, he spent 15 years at Schlumberger in over 10 countries throughout the world. And it gives me great pleasure to introduce Hani for you now, and he will introduce the panelists as well. Hani, over to you.
Thank you. Thanks very much, Simon, for the opportunity. Thanks, everyone, for attending. And yeah, it gives me great pleasure to moderate this panel of experts, really discussing a very timely and interesting topic. How can we use edge analytics and really capitalize on that to deliver value? So two esteemed panelists we have today, Vikram Jayaram and Saeed Mubarak. And I'll let them introduce themselves briefly. So starting with you, Vikram, if you want to say a couple words.
Sure. Hani, can you hear me? Awesome. Thank you, Hani, and thank you to the committee for putting this together. Really happy to be here with Saeed. My name is Vikram Jayaram. I lead the data science advanced analytics team here at Pioneer Natural Resources. Much of it is actually to cater the business intelligence, digital strategy, and innovation essentials for all our Pioneer upstream operations. My team leads the technology research and analytics product development. So we've been doing this for over 3.5 years now. Some of the interests and R&D efforts are in utilizing applied and derived machine learning, artificial intelligence, and optimization concepts in drilling, completions, geosciences, ESG, and next generation reservoir monitoring systems. Some of the building the strategic business intelligence solutions pertaining to real-time operations command center is also something that my group does for the most part of the time. Then also with some of the hydrocarbon production forecasting using machine learning and kind of utilize design of controlled experiments to derive some of these actionable insights. So along with that, we've also started with some on the edge computing side. And so this is a very exciting moment and very exciting time in the industry, and really looking forward to it. Thank you.
Thanks, Vikram. Saeed, if you would also introduce yourself, please.
Hello, everyone. Thank you, Hani, and glad to join Vikram in this panel. I'm Saeed Al-Mubarak, located in Saudi Arabia. Been in the petroleum industry for about 30 years, and across all the disciplines of upstream of oil and gas. And I'm the chairman of the SPE Digital Energy Technical section, where we basically, one of our missions there is to share knowledge about digital energy, which is digital transformation. Through the years, most of my experience or time I spent in intelligent oil fields, and till it became more of a hobby, and that's the digital transformation of oil fields. I'm pleased to join you, Hani and Vikram, and thank you for the organizers in having me.
Thank you, it's an honor. So let me kick it off with a question to you, Saeed. With the current business environment and mounting challenges, edge analytics is becoming more important. So If you can talk to us about, in your mind, what are the drivers and enablers of edge analytics in the context of digital oil fields, which you've been working on for
this is really a great question, and it's very relevant to at least our business, and especially in the oil and gas. It's a bit different there. We shall not be really driven by the advancements of technologies, but the application of these technologies and the value they bring to us. So during my journey in the intelligent fields, we came up with the motto about technologies. They're fit for purpose technologies. So whenever they fit, we really go and invest in them, be it in a smaller scale as pilots. Then based on the results, we scale up. So edge computing as a function, especially in the petroleum industry, did exist and long ago. I mean, if you go back, what exactly we want from edge computing, it's more of a reduction of latency. So we want to process the data closer to the source. And what's more even important than the data itself or processing it is making a decision out of it, using whatever experience that we have and based on the conditions there. And what's even greater of value is taking the action. Now, if you go back to history, and just prior to mentioning the drivers of it, of the edge, if you go back to history, we have subsurface safety valves, and they're really automated. And they're more of the concept of the edge is manifested there. POP is as described in the previous keynote. PQ curves used to be done in RTUs. And in fact, in every single house, if you have a pressure relief valve in every pressure cooker there. So that's basically taking an action there based on a safety issue or an efficiency issue. Now, when it comes to the drivers, and there are two. I mean, if I sum them up into two drivers, they're business drivers and technical drivers. And when it comes to business, definitely every business would like to have more of a competitive edge, at lower cost and more efficient and safe and secure operation. That's more of the business driver. And definitely from the technical part of it, especially nowadays, you will hear a lot about the communication aspects of 4G, 5G, connectivity and IoT, storage capacity, which became cheaper, and computing power as well, be it in the well site or even in the headquarters. Now, one would really ask, I mean, a layman would ask, if I have no latency, so regardless of what the infrastructure and communication is, and I have no latency, and I have all the systems in the headquarters, would I need edge? Or would I will be more of in the edge if I have, let's say, 5G and high granularity of data is more of the raw data comes to the headquarters. So basically, you will be at the edge all the time. So if you hear the first panel, keynote, there was a mention of the importance of both the cloud and the edge, especially in the oil and gas, where actions that are taken in a certain well site definitely impact the rest of the network, be it a well, be it a device, or be it even a pump. Because a production, definitely if it is basically impacting a production of a well, then that affects all the network, and be it pipelines or be it even efficiencies and other, productivity of other wells. Now, when it comes to the enablers, definitely it will require more of investment in technologies. Then what comes with these technologies, they're not the regular one. They have to be really, really reliable. And they have to have embedded analytical systems within that have more of embedded experience of those domain experts. People talk about AI and data-driven models, and they are quite, applicable, but definitely they have to be trustworthy and reliable. And in a safety, secure environment, because the oil and gas things or actions has to be really, really safe and to the environment and even to the people around in the vicinity of these wells. These equipment have to be continuously maintained, and definitely that would need fund. But more important than the technology themselves, there has to be some sort of an alignment within the organization of strategic alignment and to basically adopt the a structure that adopt edge computing. And there has to be within the operator, all the disciplines, more clarifying the business needs and expectations. And they need to be aware of the capabilities and limitations of these technologies just to intervene whenever they need to. And what's really of a great importance, and that's the last point, is the competencies of people who are operating these fields and who are basically maintaining and operating these equipments that are associated with the edge. I hope I answered the question.
Thank you, Saeed. Vikram, maybe shifting gears a little bit, could you maybe give some examples from your experiences of business value, specifically how implementing analytics at the edge can help reduce costs, improve outcomes or so?
Sure. So this is one of the primary tasks of any organization when they're putting their digital strategy, is applying a cost-effective technology in the first place, which is core to their business. And effectively underlying what we are trying to do is we want to drive efficiency across the life cycle of the well, which includes whether it is drilling, whether it is completions, or whether it is in the operations side. So developing such strategies and technologies around all the things that we see today, whether it is high power computing, right amount of the data science around it, the predictive and prescriptive analytics, all of this has to come in conjunction and has to be solved. And I completely agree with Syed, is the cost of doing this at the edge has both sides to it. One, obviously, there is cost associated with it. There is also things around when we could achieve some of these goals as soon as possible. Those are things that we have to be very careful about. So some of the examples that I could quickly think about is in the completion side, especially during monitoring our hydraulic fractures. We do see that every time we take certain measurements, and as of today, we have come across several of these new types of measurements that are happening around distributed acoustic sensing and distributed temperature sensing. These are high fidelity data. They've got very high resolution, but at the same time, they're also very buried in noise. So the question is, if you are able to frack all stages and then understand, reveal the science that comes out of it, and then you want to do something about that, you're far away from taking any decisions on the edge. And so that is why it is some of these processes, design consideration changes in your when it comes to hydraulic fracture monitoring and other things would need hardware, software, technology that has to compute things at very fast, at the same time be able to provide you that kind of information. DAS DTS technology, as you've seen, you've come across, is very dense. And sometimes, for per well or something, you're looking at about close to, even 10 terabytes per day worth of data that gets generated. So you really need to have devices that can actually process that kind of data. and make sense out of it, because you're looking at dense data that is monitoring every little fracture, crack that's happening downhole, and that has to be interpreted quickly and figure out what's coming out of it. So essentially, consider this example like as if you've gone to a dealership and brought this really nice luxury car uh, with a very, again, the value of that car as and when you are driving away from the dealership keeps on reducing. 6 months down the line, it's maybe half of it. A year from there, that's what happens. I mean, it is depreciating from when the source has actually taken place. So same thing with data also. Some of these things, some of the decisions that have to be made in that context, if they are not done at that moment, then the value of that data keeps on depreciating as and when you move away from it. And this is when we talk about the cases of edge and other things. I mean, we see this at autonomous driving these days. When you're driving a car and when all these LiDAR measurements are collecting real-time measurements of where the pedestrian is, where somebody is walking, that decision has to happen on the spot. And those complex algorithms, whether in GPUs or whatever that is processing, has to happen on the spot. If it doesn't happen, then something else is going, because your dynamic environment will keep on changing on you. You're traversing through curves, you're coming through a stop sign, all sorts of things are happening. So so just trying to put to the context of this edge computing is when coming back to that problem of hydraulic fracture monitoring, we want to make sure that there are so many design constraints that we have. Stage length, fracture, type of perforations, whether it is standard perf or tapered perfs and things like that. There is tortuosity pressure that is kind of built up between one stage to the other stage. And if that tortuosity pressure, if you can predict earlier in time, what is the design consideration change that you may have to do on the fly? So these are things that are getting developed today. And there is value for doing those kind of analytics on the spot. The other I can talk about is dysfunctions, tool dysfunctions that we have today in drilling, or monitoring any of our artificial lift systems. Every one of them have got their own design changes and they have got their own challenges. When you're looking at things such as stuck pipe inside while you're doing drilling, there are certain kind of sensor measurements that give you this information, but that has to be processed on the spot. No matter whether it is in the headquarters or whether it is at the data center, wherever it is, or close to the edge, that information has to be processed in real time and has to give you some sort of alerting system that is telling you that this particular signals don't look right. There is about to be something going to happen. Check the hook load, check the standpipe pressure or something else. There is things that we have to do that will have to make sure that this mitigation is in place. And so if decisions are made slightly late on that, it is of course it is catastrophic also. There is huge capital expenses when it comes to fishing that equipment back outside and things like that. So they are very big use cases as of today, including in the lift systems. Like you want to make sure how your ESPs are, how the health of your ESPs are, and when they're going to, if they're going to fail, when they're going to fail. We should be able to predict those things in hand. And some of that also requires some of this kind of information. So there is signals on one hand, which we are collecting. There is also the kind of hardware and software infrastructure that we have put in. They all have to come together in hand at the same time. The cost has to be effective enough, because end of the day, all operators, I'm not speaking to myself or Pioneer as such, but in general, we are being compared to the technology companies. There is high expectations from Wall Street regarding our ability of our investors to reinvest at the same time. So that is only possible if there is if we operate in the lowest LOE for all our wells. And people and technology, they all have to go hand in hand for that. So I'll kind of pause there and wanted to see what if there's anything else Syed wants to add to it. I'm more than happy to listen.
Yeah, I mean, let me pick it up from there and probably expand on that. I mean, you both mentioned the importance of course, the technological aspect, the business case, but importantly, perhaps the people and organizational structure. So maybe Saeed, you can expand on that and talk to us about how should an organization's data strategy, decision making, and actually structure overall be optimized so that you can maximize the benefits of edge analytics or any analytics for that matter.
Well, again, it's in the oil and gas business, and definitely other businesses that are equivalent. I mean, but I'll quote Dina, the keynote of the whole event here. She said, "You can have cloud without edge, but you can't have edge without cloud." And definitely in a physical setting, you can have both if you want to, or any one of them. But based on my interpretation, to have it really effective in oil field or to manage a reservoir, and then you have to have both. And let me illustrate based on experience here. Geosteering of horizontal wells, and especially multilateral wells. What is the case and the structure there with companies? They have the well site, and they have drilling engineers in the well site, and maybe geologists as well. They've got the real-time data in the well site, and that's the edge. But they have the enough capacity and appropriate infrastructure, that's a communication infrastructure, that transmit the data in real time to the headquarters, where they've got all the SMEs, be it geologists, reservoir engineers, and even production engineers, to follow up real time, and that's more of an operational thing, and to decide if we move the bit upward, downward, sideways. So it takes, just like Vikram mentioned, it's the minds and the machines to work together. And if you have a reliable communication that is quick enough, then basically you're not only in the edge, and there are people in the edge there. It's not really unmanned platform, just like the case it's let's say in cold places, just like in Russia or even Alaska or other places. And now in regular places that they have operation and they have people in the site. So they communicate with each other. So you've got people in the field, and that's the edge. You've got people in the headquarters doing the same. So if you talk about the organizational structure, is most likely to be the original company structure, overlaid with edge analytics initiatives to complement basically the thing. So the inertia usually, and we need to be really cautious when it comes to it, the inertia tends towards original company structure. And that's what I've seen, what I've experienced. And change is a bit hard, especially if you have big investments. I wouldn't say in legacy software or legacy technologies, but definitely things evolve, but strategies usually don't evolve as fast. Now, combining basically the two, the edge and the, complementing the existing infrastructure, to my view, is maybe the best option, especially, that's due to the power that you have either in the cloud or in the headquarters. So if you're talking about really predictive and machine learning and conducting more of artificial intelligence algorithms in a really fast-paced, then the computing power, in fact, they will not be at the edge, unless it's more of something that's conventional with more of a yes or no, or some sort of a logical, or really advanced and trustworthy algorithms. So combining the power of edge and the cloud we work to build an effective and cost-effective and powerful IoT solution to me for smart fields and manufacturing. Definitely what's needed there, beside the technological part of it and the strategic part of it, we need to, our companies basically need to tailor certain roles and responsibilities, giving the new environment that are associated with the new technologies or maybe the new introduced processes or workflows. And definitely they need to think of how to promote them, how to educate people on those workflows, and train them and how to implement them. And definitely, if they start really small but successful, the growth can become really fast. And so start small, maybe with the big vision, but you can really expand it quickly if you build momentum and successful stories. That's basically what I see as far as the overall structure of a company.
Thanks, Saeed. And I want to remind everybody, if you have any questions, please type them in the Q&A section, and we'll collate them and ask them. We'll have some time towards the end, hopefully, to pose this question. So please take the opportunity to do that. Next question I have for you, Vikram, is I know you've worked in NASA, Sabre, and in academia previously. So perhaps you can give us some examples of cross learnings in the realm of edge analytics, either from other industries or maybe ones that we're doing in oil industry that could be ported to other industries. So backwards and forwards, if you like. Just talk to us about cross learnings. You might have.
Absolutely. So several years back when I was working on my PhD, there was one of this problem that was given to us by JPL, which was trying to do joint compression and classification of sites, of basically imagery sites from multidimensional images. So you're looking at satellite imagery that constantly flows over our the lay of the land, and they're of different kinds. Some of them are monitoring vegetation, some of them are for climate, some of them or for weather models and all sorts of stuff, so that there's different sensors that NASA has put together. One of the bigger challenges that we had was around the fact, especially the problem that was given to us was around this, the cost of transmission of data. And again, like I just explained, the problem of learning the insights and interpretation later in time, that there is a cost associated to that, wherein if the insights are not immediate, then you lose that advantage. So in one such problem wherein they were mentioning that if there was a wet method wherein we had onboard processing, because all these camera systems that collect these imagery, and by the way, they collect in multiple dimensions because they're constantly changing their wavelengths and things like that. The process time that is taken by the time it is all packed together and sent to the ground stations, and it goes through one of these national labs, and then they get processed, is and the interpretation comes out, the season would have changed, something else would have happened, and then all of that information that was collected was not that useful. Of course, the science comes out for everything. There is learnings that comes out for everything. There's no doubt about it. But the actions that were supposed to be taken right at that moment itself could not have been done, because there was no way all of this could have been processed at the satellite sensor platform itself. When it is collecting information, it is processing then and there. So what is it that is needed? Of course, there is hardware needed. There is fast processing, high performance computing that has to be put on board of the satellite systems that could process these images so quickly. And then there is also kind of your software side of things, that is, some sort of compression that is required. I spent majority part of my early career in developing compression algorithms. Again, it had nothing to do with the oil and gas industry, but that was one of the things that I did. It's also part of the JPEG 2000 standard. And what we do there is when we are able to make interpretation in compressed domain of the signal itself, and still be able to figure out that edge analytics that we can provide so that there's decisions could be made. So companies like NASA has been working on that for the longest time. Their national labs have been working, national labs work on this problem. And there is also with autonomous driving that has come up so big right now, that you would, if there is a training set for any given data, if you want to see the dense training set, there is, you should go online and take a look at NVIDIA or any of their sites. There'll be vast amount of voluminous scene data that is available. It's just basically car is moving and there is scenes all around you. Huge training sets. In that there is labeled training set also. They have labeled it. Here's a pedestrian that is coming in. Here's a person that is crossing. Here is when you could see the building approaching or something else happening. And they have made this all open source. Why? Because they want to have the best set of minds across the world go build algorithms, go build fast algorithms. And the faster they are, they could be put on all these systems or GPUs that are calculating or whatever hardware that is there on the car that can do this on the fly, so that the decisions can be made quickly. Look on the other side of the coin. If the decision were not to be made quickly on that, or there's this little bit of a latency also, it is somebody's life, and something very catastrophic is going to happen there. Again, these are things that the oil industry is taking a look at, as to what it is, how we can improve our health, safety, and environment side, ESG side of our things, especially in case of our methane emissions and detections and things like that. There is today we have point sensors that are being placed across our field. Anytime there is process-related emissions or non-process-related emissions, you want to be able to figure out what is happening to your emission as your emission portfolio. And if you're able to detect it, you immediately are able to set this an alarm that the lease operator can go take a look at it, make the checks and things like that. But imagine the difficult side of that problem, right? You have your well sites at remote locations. You have the environment playing the factors. There is wind that is flowing from all sorts of places. Then you have your other operator friends all around you, also having their own, their own equipment on the field, where you never know which side, which one is coming, and how do you localize that problem. So the problem of localization, detecting it and setting an alarm, everything has to happen together if you want to take a decision on that. And not that you are looking at the data 10 days from today, where you've really not really helped your emission portfolio so much.
Well, so
go ahead, Sai.
Well, you brought a really good example when it comes to the self-driving cars and the data sets that are available in the public domain with all basically the tags within the the data itself. That's more of impossible to the oil and gas business to have more of data of production data reserves and posted in a public domain, and how things even technologies operate. That's something maybe that would be worked out. And the other thing is, I mean, if it's okay that I, it's
absolutely,
it's
absolutely, yeah.
It's the time unit that we discuss here is, and defining what real time is, and that time unit has to be really clear. It's just like if you have the data, you do the analysis, and that can be immediate analysis, more of a logical thing. Then taking the action is just like in self-driven cars. Then basically they can maneuver, they can take, park, and they can stop. And when it comes, that's an immediate action, especially that time unit more of let's say microseconds. But when it comes to different actions in the oil and gas, it's just like let's say, changing an artificial lift pump. I mean, it's ESP. Well, and let's assume you detect the thing in the edge and it failed on the time that you even expected. Then what's required there is basically maybe a rig to pull it out and put a new one that's more of a specific design that's designed for the current conditions of the field and the well production, and to provide you with that specific target. Then you need to basically design it, manufacture it, and that's a leading time and all of these things. So even if you're really, really quick, that time unit can be 2 weeks, 3 weeks, 5 weeks. So that's the thing. So building that infrastructure, even the communication infrastructure, the storage infrastructure, the total investments of technology is directly associated with the time units that you're basically, making, from taking the data to making not a decision, the action. Because data by itself, analysis by itself, if the action is too late, just like you stated in NASA example, then it's just too late. Conditions are completely different. Even the technology that we designed, pre-designed, might not fit. And we're looking for a technology that provide you with the objectives that you're looking for and the value that you want to attain. That's just a point to highlight.
Absolutely, Syed. I completely agree with you. Especially with this artificial lift systems, we have seen that, not just us and other operators also would have a very similar problem, is that amount of time it takes. By the time you would have figured out when the certain lift type has actually gone down until you line up of your rigs to come over and take care of it, there is that latency that is there. Again, this is all business processes that have to come in together. This might not be the best edge example because there's a lot of other things that has to happen before that edge can become really effective, as you've just pointed out. But certainly in some of these other spaces like ESG, where this is I wouldn't say this is relatively new to us, but this is all happening right now. The action that has to take place to go fix something, to fix a leak, to make sure it is not, to make sure that your LDAR program on a yearly basis shows that reduction in emissions is now the new ask for all the oil companies or all the operators. And investing in those technologies, and especially they have direct relationship to how the European investors look at the shale operators, or somebody else would like to take a look at it. They want to see what is your ESG portfolio looks like.
One of the examples in the field that I feel like it can be done in the edge immediately. It's auto calibration of multi-phase flow meters, for instance.
Yes.
And these gauges, auto calibration of gauges, when we have those capabilities to detect, let's say, deviation or a drift, or the need for calibration, that might be done all at the edge. Valve actuations, even maintenance. I'm talking about scheduled maintenance. That can be done in the edge at a safe and secure environment, and to gain the trust and the confidence even of the operators themselves, because they usually go to the field to witness and make sure that things are all right, because any failure of things relevant to wells may be catastrophic, just like you say, the leak close to a residential area, or maybe you know how it goes in the oil fields. But definitely there are some applications, and this is what we basically we look for applications. It's not only the technology itself.
Thank you, guys. I think we could go on actually for another hour easily with all the great conversation, but actually we've come to the end now. And you've actually answered a couple of the questions that came across, like, what are the most beneficial or most compelling applications? And and kind of where can you and can you not look at pure, edge analytics. But thanks very much for a great conversation, and really appreciate, and hope some of you can join us in the breakout room as well for more discussion.
Thank you,
So,
Hani.
over to you, Simon.
Thank you.
Thank you,
Vikram.
Simon.
Thank you.
Okay, thank you
Thanks,
guys. And yeah, there are some questions. Just David and Andrew, head on over to the speaker room, and gentlemen can answer your questions there. So look forward to welcoming you all back in 20 minutes time for the next session. So thank you very much.
Thanks.
Thank you.
Thank you.